of acid into water. I could have left the question. The question would have been just as well like that. It's predict the major product expected, or I could say explain the result. So let's have to take the first question. Predict the major product expected. Explain how to do it. What I'd like you to imagine is, gee, this is an alcohol. It's going to protonate. It's going to create a leaving group. So we're going to protonate the alcohol. Create a leaving group, which will be H2O. And when it leaves, and we'll also put it under here that we're going to heat this thing. When it leaves, we end up formally with a positive charge there. The only nucleophile that we have present in the whole system is water. Water can attack here to go back to starting material, and water can attack here to go on to product. And if you recognize the hints that I'm trying to give you, delta, heating, you'll say, I'm working under thermodynamic conditions. And the two products possible from this reaction is some starting material remaining or regenerated, and this compound, and you'd say, this is the more substituted alkene. So this will be the major product, and that will be the minor one. So it's a nice summarization. And probably in this case, because it's tri-substituted versus mono-substituted, it might be as much as 95% of this and 5% of that one. So you can convert one into the other if you know how you know what kind of reaction conditions you're working under. And it also depends on the structure. And as a couple of sort of problem sets that I'm going to leave you with. That you can think about as an additional problem set. Supposing I started with this. Plus HBr. And let's say we're going to work under, 50 degrees, which you should suggest is going to be high, or at least thermodynamic control. What would be the major product? And two questions you need to ask yourself. And the first thing, the most important thing is to say, first of all, I'm going to get the best possible carbocation. So you have to sit down and say, which double bond do I want to protonate? Do I want to protonate this double bond, or do I want to protonate that? And you draw them, and you say, okay, can I make a decision which is the better one of the two? And if you do them, they both have to be allylic, for sure. And then you look at the two possible allylic, and you decide which is the better. And then you look at that one. You say, under thermodynamic conditions, that carbocation is going to give this particular thing as the major product. Combining, so that's the first one. We're going to combine some acetylene chemistry with allyl chemistry. And it's a similar kind, but it shows you that we can take, supposing we start off with the molecule acetone, and we discussed to a considerable extent that if we react acetone with an acetylide anion, just the parent compound, and I wanted to draw that one, but I never seemed to be able to see it properly. I wanted to draw that one in blue to keep it, to see how the connectivity works. We would get first reaction after workup.